Hello students, today we'll discuss IB Math Analysis and Approaches Higher Level Paper 3, May 2021, Time Zone 1. You can and sometimes should use calculator approved by IB Examination Board. My name is Nariman Malim. I'm located in Baku. Here you can see my mobile and email. This is the cover page of Paper 3. Paper 3 consists of two questions, long questions, and they give 1 hour only for these questions. This question asks you to explore the behavior and key features of cubic polynomials of the form x cubed minus 3cx plus d. Consider the function, so they put instead of d2, for x real and c real. The graph for c minus and 0 are shown. So here we don't see even inflection point, but here I see obviously horizontal inflection point. Here we also have inflection point, but it is not 0. On separate axis, sketch the graph of y equals fx, showing the value of y-intercept and the coordinates of any point with 0 gradient for c equals 1 and c equals 2. Write down an expression for f prime. So first case, c equals 1. I use calculator. It showed me that local minimum is exactly on x-axis. This is why we have two x-intercepts. And also I found maximum point and y-intercept. For c equals 2, we have a bit different situation. Now we have, because our maximums minimums are not on x-axis, we have 1, 2, 3 intercept on x-axis. So they ask us to find first derivative. We did it. Oops, I did it with mistake. Constant disappear. Right. Hence or otherwise, find set of values of c such that graph has a point of inflection with 0 gradient. That is, so you find first derivative, second derivative, and they should be equal to 0. This happens at point when c is 0 and point is of inflection is 0. Another question, one local maximum and one local minimum point. So we have second derivative equal to 6x. So when x equals plus c, we have local minimum. Well, x equals minus c, we have local maximum. So c more than 0 give us situation with local maximum and local minimum. No points where the gradient is equal to 0. This is C, no points where C is, when C is negative, because you can't take root of negative number. Given that the graph of y equals fx has one local minimum and one local maximum point, shows that y gradient of local maximum is this and y gradient of local minimum is this. Critical points are minimum x plus square root of c and maximum x minus square root of c. Let's evaluate the function at this point, and we have the value of local maximum and local minimum. Hence, for c more than 0, find the set of values of such that the graph has exactly one axis, x-axis. So c equals 0, c more than 0 is considered. First, such situation, exactly x-axis, happens in case when local maximum is below 0, when c less than -1, so this case is rejected. Or local minimum is above x-axis. This happens, so the values we calculated, if local minimum is above x-axis, c is between 0 and 1. Then question E, at 3i, exactly 3 axis, x-axis intercept. Minimum at 0, maximum at 0. This happens when c equals 1. That was cases for, just a moment, double I. Double I is exactly 2 axes, exactly 3 axes. We have another story. 3 axes, maximum above 0, then c is more than -1, our minimum below 0, then c is more than 1. This case is accepted. Consider another function of the type, but instead of 2 we have here d. Find all conditions of c at d such that the graph has exactly one x-axis intercept, explaining your reasoning. Case c less or equal to 0, we have no critical point, so we don't consider this case. Case c more than 0, then maximum should be lower 0. So they ask us for 3 x-axis. Either maximum should be above 0. In this question, they want us to find all conditions on C and D such that the graph has exactly one axis intercept, explaining your reasoning. When C is negative, we don't have real critical points. It means that no critical point, one x-intercept. Case 2. C more than 0. So exactly one intercept can be either minimum should be above 0, then we get d more than 2c 3/2, or local maximum point below 0, d less than -2 3/2.